Hi, my name is Sonia, and today I'll be talking about triple beam balances and electronic balances. Electronic balances and triple beam balances are similar in the way that they both measure small solid substances. However, differences between the two include that triple beam balances measure mass and electronic scales measure weight. Another significant difference in the two measuring devices is technology. Electronic scales use computerized component to determine the weight. Electronic scales require the use of a microchip to make a calculation. Conversely, balance beam scales are very much a manual process. You must physically place two objects together and compare the mass. Both devices have similar usage. However, triple beam balances are primarily used for precision, which is why many types exist. For example, mechanical baby scales, bathroom scales, hanging scales, kitchen scales, eye-level beam scales, top-loading dial scales, and Baker scales. When you need fast weight and exact precision is not a requirement, an electronic scale will suffice. The triple beam balance has three beams. The front beam reads in 1 gram increments from 0 grams to 10 grams, middle beam reads in 100 gram increments from 0 grams to 500 grams, and the far beam measures up to 10 gram increments from 0 grams to 100 grams. To measure the mass of an object, you must calibrate the triple beam balance and place the object on the pan. Once the object is on the pan, you adjust the eights so that the pointer at the end of the scale points to 0. If the pointer is above the 0, then you can move them to the right. If the pointer is beneath the 0, then you can move them to the left. The electronic balance is slightly easier to use. You simply need to press the 0 button, then place the object on the pan. Balances had first been used in ancient Egypt to measure precious metals such as gold. The first balances had been used simple scales on a single fulcrum to measure the relative mass of objects. Triple beam balances had been invented later, though they cannot be attributed to a single inventor. Both of these types of balances are commonly used in laboratories and classrooms to measure out solid substances for use in experiments, though they can also be used for more casual use, such as measuring items in a grocery store, which is why there are so many examples of balances. Many lab experiments use electronic balances and triple beam balances. In the gravimetric analysis lab this year, an electronic balance is vital for measuring the mass of sodium carbonate and calcium chloride. Because the mass of the reactants determines the mass of the product, thus helps one determine the percent yield. Triple beam balances are also helpful for understanding density. Getting the density for something such as a metal requires a mass value, so triple beam balances can easily be used to measure the mass of a metal. Even though triple beam balances are less accurate compared to electronic balances, they can be used for larger objects. Most labs require some form of measurement, such as the Calculating R lab. Even though the Calculating R lab involves gases, the initial mass and the final mass of the lighter still need to be measured to determine the amount of butane gas released. There are many errors that can happen if misused, such as giving inaccurate measurements, either too big or too small. The balances are not calibrated properly. Thus, you need to calibrate the balance every time before you measure it. For triple beam balances, if you don't clean them regularly, dirt and lint can build up on the magnets and cause the beam not to move properly. If you hold the triple beam balance by the trig loop or damper as you transport it, you might damage it and bend the damper valve, causing the beam to stop moving. For electronic balances, atmospheric conditions such as temperature, air circulation, and static electricity can affect the balance and cause the measurements to fluctuate repeatedly. In conclusion, triple beam balances and electronic balances have many things similar in common and also many differences and are used for different purposes. However, both are very useful in the laboratory. Thank you!